So this chapter we'll be talking about covalent bonding, which you got a little preview of with the activities you've done so far with the Lewis structure activity. So a couple characteristics of covalent bonds. This is a bond between two nonmetals, or a nonmetal and a metalloid. So that differs from an ionic compound. An ionic compound, remember, is the combination of a metal and a nonmetal. So you can determine if an atom or if a bond is ionic or covalent by knowing the difference between those two types of bonds. So again, covalence between two nonmetals, or a nonmetal and a metalloid. And looking at your periodic table will help you to determine that. Covalent bonds also share electrons, so their outer energy levels overlap one another, and this is going to result in the electrons being shared. Again, this differs from an ionic bond because in an ionic bond, one atom is gaining electrons, the other atom is losing an electron. So there's actually a transfer of electrons. Our overall goal, though, is still to make these atoms stable, and they still want to reach octet. So remember, that means they want 8 valence electrons in their outermost shell, with the exception of hydrogen, it only wants 2. So you can see in these models here, you can see the inner shell electrons, the valence electrons, and you can see where they're sharing them and which atoms are contributing to that bond, which is what you guys saw with your Lewis structure activity as well. Couple other characteristics, they have very low melting and boiling points, which again is the opposite of an ionic bond. So if you think of sugar, sugar is an example of a covalent molecule that's covalently bound, and if you put sugar on the stove in a pan, it's going to melt relatively easy to make caramel. Most covalent molecules exist as gases or vaporize readily at room temperature. That does not mean all of them do, just most of them are in the gaseous state. There are liquid covalently bound substances, and there are gaseous or solid, covalent substances as well. They do not conduct electricity in water, so they cannot form an electrolytic solution. Again, opposite of what an ionic bond was. So if we were to take sugar, dissolve it in water, and put those conductivity probes or testers that we used in class into that solution, it would not conduct electricity. When we do have covalent molecules that are in the solid state, they are very soft, and again, they do not conduct electricity either. And then the last thing we want to talk about today is the strength of covalent bonds. When different atoms bond together, there's a bond length that we talk about, and that really tells us the distance between the two bonded atoms. And the strength of that covalent bond is going to depend upon how close or how far those atoms are apart from one another. So as the bond length decreases, the bond strength is going to increase. In other words, the closer the atoms are to each other, the stronger that bond is. The further away they are, the weaker that bond is. Now, if you think of that, the stronger the bond, it would be more difficult to break that bond. So if you can imagine, if we have two sticks, for example, okay, so you have one really long stick and you have one stick that's shorter. The larger stick is going to be easier to break than the smaller stick is. Okay, so you can kind of think as that stick is connecting those two atoms together. So the further away the atoms are, the easier it's going to be to break that bond, because the strength is less than it would be if those atoms were closer to one another. So when we talk about bond strength, we're talking about the energy required to break a chemical bond. Right? The stronger the bond, the more energy needed to break that bond. And then we have 3 what we kind of can refer to as types of covalent bonds. And this is what you guys kind of are getting to see with that Lewis structure activity. And we're going to actually go through these examples when we talk about your Lewis structure notes and your activity next week. So we are going to stop there for today.